Today we are going to start solving this example. This is a combined example for the 4-step process. It covers 2 steps, the mode choice and the traffic assignment phase. As we can see here, we have 5 zones, and the 5 zones are here, and this is the OD matrix. This is the trips, the person trips between zones, and we can see that in the zone itself there is 0 trips. So these are the intra-zone, the trips between the zones. This is what we call OD matrix. That means we have from zone 1 to zone 2 3,700 trips going, and from zone 2 to zone 1 we have 2,000 trips, and so on. Clear? Okay. The mode choice, we have 2 modes, cars and buses. And as we can see here in the figure 2, we have 2 bus routes. We have bus route that covers from zone 5, between connecting zone 5 and zone 2, and we have another bus route connecting between zone 4 and zone 2. That means, what does this mean? This means that we have between 2 and 5, okay, between 5 and 2, and we have between 2 and 4, this is, and 4 and 2, so this is 4 and 2, and 2 and 4. These trips are subject to mode choice. In other words, these volumes between 2 and 5 and from 5 to 2, the drivers or the travelers, they have a choice either to drive by car or go by the bus. And the same applies for trips between zone 2, 4, and here between 5 and 2. So between both, so these are the trips that are subject to mode choice. So let's check here. The utility function for the car is minus 0.4 access time multiplied with the access time, minus 0.6 multiplied with the travel time, minus 0.005 multiplies with the parking cost. And this is for the bus. Minus 0.6 waiting time, 0.4 ride time. That's basically the ride from origin to destination, and 0.005 multiplied with the ticket price or ticket cost. The ticket was 100 halala, which means 1 rial. Okay. Bus waiting time was 10 minutes. On route 1 is 10 minutes, and on route 2, okay, so route 1, 10 minutes. Here in route 2, it's, so let's do this. Let's get the mode choice for OD 2, 4. This is route 1. So the utility function for the car, car equals what? Minus 0.4 multiplied with the access time. So the access time, I think it's the access time for the cars, I think it's the same on both routes. So it say here that, okay, the parking cost equals 0. Currently, cars are allowed to park on all zones for free, parking 0. And the average access time, okay, to parking areas is 10 minutes. So here, access time multiply 10 plus sorry, it's not plus, it's minus. Minus 0.6 multiply the travel time. What is the travel time between 2 and 4? Here is 2 to 4. 5 plus 5, so it's 10 minutes. Minus 0.005 multiply 0. So this is the current the current utility coefficient. So we have 0.4 multiply 10 plus 0.6 multiply 10
minus 10 المفروض ده.
minus, yes. So this will be 10 minus 10. Utility for bus equal minus 0.6 multiply waiting time. So the waiting time for route 1 is 10 minutes as stated here. So multiply 10 minus 0.6 multiply the travel time, bus ride time is 25% higher than the travel time in the private car. So that's the travel time in private car. So we say that it's 10 multiplied with 1.25. That's the ride time for the bus. Minus the ticket price is 100 halala. So here it's 1.005 multiply 100. So the utility function here will be 0.6 multiply 10 minus 0.6 multiply 10 multiply 1.25 minus 0.005 multiply 100. So this will add up to minus 14. Okay, so the exponent for this, e minus 10 equal,
دكتور
yes,
هنا 0.4 مو 0.6 عند الباص.
I'm sorry, yes, thank you.
You're welcome. 11.5 جاتني دكتور.
11.5,
0.5.
thank you. What's your name?
عبد الله.
شكرا يا عبد الله.
عفوا.
So here e to the power minus 11.5. So shift e minus 10. So this will be 4.54 multiply 10 to the minus 5, and here this would be 1.01 multiply 10 to the power minus 5. So the add up for these is going to be 5.55 multiply 10 to the power minus 5. That means the percentage or the number of trips in cars equal 4.54 divided by multiply 10 to the power minus 5 divided by 5.55 multiply 10 to the power minus 5. Multiply what are the number of trips between 2 and 4. 2 and 4, 1900. And we'll do the same for 4 to 2. Those trips are going to be split between cars and buses. So this would be 4.54 divided by 5.55 multiply 1900. So we will have 1554 trips, and the 400 is going to be splitted into only 327 trips. So this, we're going to slash it, and this slash it, and instead we are going to put here 1554, and here we will have 327. Okay, we will do the same but for root 2. So for root 2, now we do the mode choice for OD bear to 5, that's root 2. So what we have here, we have the utility for the car equal minus 0.4 multiply access time is 10. I think it's 10 across the board, right? Multiply minus 0.6 multiply the travel time. The travel time between 2 and 5, it's 8. Minus 0.005 multiply 0. So here we will have minus minus 8.8. And the exponent for this, e to the power minus 8.8 equal 1.507 multiply 10 to the power minus 4. The utility for the bus will be minus 0.6 multiply the waiting time here for route 2, it's 15 minutes, minus the ride time, it's 0.4 multiply the ride time. So here it's 0.4 multiply the ride time, which is 8 plus or multiply 1.25 minus 0.005 multiply 100 halalas. So here this would be 0.6 multiply 15, 0.4 multiply 10, 0.005 multiply 100. So here we will have 13 minus 13.5. And the exponent to minus 13.5, this is going to be a real small value. So this is going to be 1.37 multiply 1, okay, multiply 10 to the power minus 6. If we add both values, so that's the sum of the exponent. Let me just check something. 0.6 multiply 15. 0.4 multiply 8 multiply 1.25. That's 0.005 multiply 100. Yes. So if when we add these values together, we will have 1.507 to the power minus 4 plus 1.371 to the power minus 6. The addition 1.507 exponent minus 4 plus so it's basically going to be 1.52 to the power 10 minus 4. That means trips in cars will be in this case it's going to be 1.507 multiply 10 to the power minus 4 divided by the sum of the exponents. So 1.52 multiply 10 to the power minus 4 multiply the trips. So we have two, sorry, we have these values that are going to be splitted. So we have the first value, it's 4700. So here we have 4700, and the second value, that's the 3300 trips. So basically this is multiply 1.507 exponent minus 4 multiply 4700. So this will be 4657 trips, and this would be 327 trips. Okay, we're gonna just stop here for a while, and I need your reflection on this current situation. Okay, what are your where is your observations on this? So based on this was going to be slashed, and only 4657. It didn't drop that much, and the 3030 is going to be 3270. Do we have any significant drop in the trips? No. Most of the trips for route 2, most of the trips are going by car. So what do we need to do? Let's do just step B. So we are done with the step A. Let's go to step B. Perform traffic assignment step using all or nothing method. What do we mean with all or nothing method? We mean with all or nothing that we select the shortest path between each origin and destination and start assigning the traffic volume. Okay, so let's start here, and let me just make a copy of the network, and we are going to start adding volumes on the network as we go. So let's just put this one here. Okay, how many links do we have here in this network? We have let me call this node X. So we have links. This is link 1. Let's call it A, B, C, D, E, F, G, H, J. Now, for all or nothing, we are going to assign based on the shortest path. So for zone 1 to 1, there is for zone 1 to 2, zone 1 to 2, which is shorter, going this way or going this way? So it's going this way. So what's the volume here? It's going to be 3700. Okay, and the other zone, the other direction. So we are done with this, and here it's 2000 plus 2000. So the total will be 5700 vehicle per day. So now we are done with this volume. Zone 1, 2, 3. 1, 3. Okay, the quickest route or the fastest path is going to be through this link. So that means this link. So let's make this. So here the link and the volumes. So link F, we had volumes 3700 and plus 2000. Link, let me just reorganize this. We have link A, B, C, D, E, F, G, H, and J. So this is link F. So we have 3700 plus 2000. Okay, let's go to zone 1 to zone 3. Zone 1 to zone 3, 1 to 3. So it's going to use G and C. So here is the C and here is the G. What is the volume? 1000. What's the other direction? 4200. So here we have 1000 plus 4200. And here we have 1000 plus 4200. And these volumes are out of assignment. Let's go zone 1 to zone 4. Zone 1 to zone 4. That's the shortest path. GA. So that's GA. So we're going to assign here 1400. Okay. And 1400. And both will go also on A. Okay, so we are done here. Zone 1 to 5. Zone 1 to 5. Is it going to go this way or go this way? It's going to be GJ. Because H directly it's 10 units. And here is going to be 4 plus, it's going to shorter to go through X. So G, add here 4200 plus 1 to 5. Okay, so that's 5 to 1. Okay, that's 1 to 5 and that's 5 to 1 plus 1800. For zone 2, okay, we have 2200, 2200 to zone 3. Zone 2 to 3. Which route is better? Going direct on link D or going on link E, so then C? E then C, because this one is shorter. So we have E and C. What is the volume? I think this one is done. It's 2200 plus the 3900, and the same volume will go also on G. I'm sorry, it's going to be going on E. 3900 plus 2200. Clear يا شباب? From zone 2 to zone 4. Okay, that's the one that we slashed here. From zone 2 to zone 4, we will have 1554. Okay, and 327. 2 to 4, so you are going to add on E and A. So we have 1554 plus 327. And this will go also on A. 1554 plus 327. And these volumes are slashed out from zone 2 to zone 5. Zone 2 to zone 5. So it's going to be E and J. So we are going to add to E 4,657 plus 3,270. يعني يا شباب الفوليوم ما بين 2 to 5 ده اللي احنا عملنا له split، وفروم 5 to 2 هنا اللي هو احنا عملنا له split وطلعت الفاليو دي. واضح؟ So here 3,270 I'm sorry. Here 39. Okay, so that's E and J. J is here, so we have 4,657 plus 3,270. Plus, we go to the third rows. These values are done. We have only 2,800 and 400. This is between zone 3 and zone 4. 3 to 4 is going to take this route, the CA. Because here it's 12, here it's 4 plus 5, it's 9. So it's going to be on link C, add this volume 2,800. So that's the 2,800 slashed, and zone 4 to zone 3, 4,900 plus 4,900. The remaining now from zone 3 to zone 5, from zone 3 to zone 5 is going to take this route, only 7 units. So we have to add to C this 4,400 plus 4,400 plus 4,300. And this will go to J. 4,400 plus 4,300. The last from zone 4 to zone 5, from zone 4 to zone 5 is going to be this way. So it's going to be A and J. So it's going to be plus 1,200 plus 600, and here plus 1,200 plus 600. This is when we add all these volumes. Okay, I need someone now to help in summing these volumes all together. Here we have total volume in this link. Okay. In this link, link C, we will have 27,700.
السلام عليكم يا دكتور.
عليكم السلام ورحمة الله وبركاته.
اعتذر عن التأخير يا دكتور، كنت في اختبار توني طالع.
That's okay. 1,400 plus 1,400 plus 1,554 plus 327 plus 1,200 plus 600. So this one is 6,481. These are trips. Here this is gonna be 5-7 trips, and this will be 1,000. Okay, so this is 5,200 plus 2,800 plus
14,000 دكتور. 14,000.
وانت ساكت دي يعني ما تقول من بدري يا اخي. طب واللي هنا؟
ثواني بس.
184
هنا 184.
الأخيرة.
Yes.
27.
184 2
Yeah 27.
27 trips. And the one in the middle? Link E. This is 1500.
159
08.
08.
Okay, great. So what can we see from here? We can see that we have congestion, okay? And actually, the highest volume, we have links that has 0 volumes, correct? These are link B and link D. Why? Because they have the highest link travel time. So people are avoiding these and going on the shortest path. But guess what? Due to this congestion, these links are not going to be acting at these travel times. It's going to be congested, so it's going to be the travel time will be higher. Now, what we want to do, okay, we want to try to improve the situation. What can we do? We have bus route between 4 and 5. So this way we can affect these links. A, J, E. So we have A, J, E. As you can see, those links, they have high volumes. It's not as high as link C, but link C, we have nothing in hand to do for this. Otherwise, we might recommend adding a bus route or bus service in this link, in this for this origin. Okay, so now what we need to do, we need to come up with some modifications. What kind of modification can we do? Need your suggestions in order, okay, to try to shift the population from using their cars and start using the bus. Okay, can I get some ideas?
Reduce the ticket price.
Reduce the what?
Ticket price.
The ticket price. Okay, how much we are going to reduce it?
I'm not sure.
Let's go an extreme. Who is speaking?
Faris.
Faris, let's just check this to see how much does it worth reducing the price. Is it going to be significant or not? So we have 0.6 multiply 15 and 0.4 multiply 8 multiply 1.25. So basically the price, if you assume price 0, I will go with your suggestion 0, here is going to be 13. Did we change significantly? Faris?
Yeah. Yes.
The change is insignificant. So we need to make a significant change. Okay? So
Okay.
what can we do with these parameters in the utility function? What are the parameters that we can change? First of all, for the car, we cannot change the access time. The travel time, I don't think we can do anything. But the parking cost, we can enforce parking cost, because it says here that currently cars are allowed to park on all zones for free. Parking cost is 0. So we might need to increase the parking cost. Okay, but let's say, for example, we are going to increase the parking cost to be maybe 200. How much is it going to affect our utility function? If this one was, for example, 100, if it was 100, this will be basically I'm sorry, this is 100, this is 1000. 100, the utility function will be minus 10.5. Again, the significance here is not, the improvement is not that significant. Even if we come here, this is 13.5, this will be minus 9 point, if this is became 100, 9.3. The increase is insignificant. So let's go and look back at the utility function and see what else can we do. Can we change the ticket price? Yes, but as we can see, the change is not significant. Right time, can we change? No. Waiting time, can we change? Yes. How can we change the waiting time? The waiting time depends on the frequency of the buses on the route. So, for example, every 20 minutes, there is a bus coming. So here, for example, let's say the bus waiting time for route 1 is 10, and for route 2, it's 15 minutes. That means we have 4 buses per hour in that route, and here we have 6 buses per hour in that route. So here, especially for this route, the situation is not good. So actually, we are going to do 2 decisions, changes. One, make car parking fees in zones 2, 4, and 5 equal, let's make it 200 halalas. Okay. 2, increase bus frequency. يعني بدل ما يطلعوا اتوبيس مثلا 4 اتوبيسات في الساعه يطلعوا 5 او 6. bus frequency on route 2. مش هو ده اللي كان فيه المشكله يا شباب؟ اوكي. to be 6 buses per hour. يبقى هنا ال waiting time يصبح becomes 10 minutes. يبقى let's check the utility function. The new utility functions. Let's check on route 1. Route 1 only we changed the parking fees, but the frequency didn't change. So U car equal minus 10 minus 0.005 multiplied to 100, which is minus 11. U bus, utility for bus, is basically the same, did not change, minus 11.5. For route 2, both are going to be changing. So we have here utility for car equal minus 8.8 minus 1, so equal minus 9.8. And utility for bus equal minus 13.5 plus 0.6 multiply 5, because there is a reduction here. Okay, this is going to be reduced to be 10. So the delta is minus 5. So minus 5 minus, it becomes positive. So here this will be 10.5. Let's calculate the exponent for minus 9.8 and the exponent for minus 10.5. So here exponent minus 9.8. This is 5.54, 10 to the power minus 5. Hold a second. And for the bus, it's going to be 10 to the power 4, so it's going to be 2.57 multiply 10 to the power minus 5. So the sum for these is going to be 1.8, 10 to the power minus 5. So the number of trips in cars equal the 5.54 multiply 10 to the power minus 5 divided by 8.11 10 to the power minus 5 multiply, I think it was 4,700. These are the values. 4,700 and 3,300. So this would be 5.54 8.11 times 4,700. So the number of trips in cars, it's going to be 3,210, and in the other direction is going to be 2,254. So these are the number of trips. As you can see, there is significant, there is significant drop between these values. It was here 3,000, 3,200. Now it reduced by 1,000. Here it was 4,600. Now it's 3,200. There is 1,400 difference, as you can see. So the change on the traffic assignment would be noticeable. So basically here, what are the links that are affected? The links that are affected are going to be this link, E and J and A, I think. I think it's E, J, and A. These are the links that are affected. Let's check and to see the other volumes. For route 1. For route 1, we have here E minus 11 equal shift E sorry, shift E minus 11. So this is 1.67 multiply 10 to the power minus 5, and here E minus 11.5. So here it's 1.013 10 to the power minus 5. And the for both is going to be 0, no, I'm sorry, 6.2 10 to the power minus 5. So percentage or trips in cars equal 1.67 10 to the power minus 5 divided by the sum, which is 2.68 10 to the power minus 5, multiply when we have 1900 and 400. So this will be 1.67 divided by 268 multiply 1900. Okay, so this would be 1183 trips. These are trips, by the way. And this would be 249 trips. So let's go back to our original table here, and let's check what are the changes that we're going to have in this situation. So basically the new trips, this one is going to change, okay, because it was 1554. So this is going to be changing, and this is going to be changing. It's going to be replaced with 1183, and here 225, and this is going to change accordingly. Okay, and this is the change is not going to be that significant, but the change will be somehow significant here, because we have a drop on this one, this one, this one, and this one. So the new volume here will be 3900 plus 2200 plus 1183 plus 249 plus 3210 plus 2254. So these are the volumes here. If we add all of these together, this will be 3900 plus 220 plus 1183 plus 249 plus 3200. The total volume here will be 12,996 trips. As you can see, there is a significant drop, okay, between here and here. We have 3,000 trips drops. This drop is significant, and it has a significant impact on level of service for that segment. If we do the same, we will end up with a reduction also here. Okay, but here is going to be limited only to those values, and the drop will not be at the same drop here. Any questions so far? Okay, let me